This video is going to go over some basics of physical properties and physical changes of matter. So some properties we're going to go over are both physical and a little bit of chemical we'll mention. Physical properties are just the constants about a particular substance. We can measure, observe them without changing what it is. Things like mass, volume, length, things that depend on how much you have, are considered extensive physical properties. Properties like density, melting points, boiling points, solubility, those properties do not depend on how much of a sample you have. So if I have 3 different samples of water, different amounts of them, they're all going to have the same density, they're going to have the same melting and boiling points because they're all the same material. So that's probably the most important one when we deal with questions that will come up. A little bit about chemical properties. These are just behaviors that a substance will follow when they react with other substances. So something like flammability, how well it reacts with water, those are examples. Now, changes of matter, we have both physical changes and chemical changes. A physical change is a change that does not alter the chemical properties of a substance. There's no new substance that forms after the change, so we're not changing the identity of the material. Simply the particles get arranged differently. So this can be like changes in the phase of matter. So solid going to a liquid or a gas going to a solid. The appearance of the material can change, the shape or size can change. So this is considered a particle diagram. So this particle has 2 atoms in it. When we go through a physical change, we're going to see the particles just get rearranged. This would be an example of like a gas going into a solid. The particles are just moving closer together, but we'll still have the same combination with what we'll call a compound when we learn that in the next couple of videos. A chemical change, though, is a reaction in which the composition of the substance is changed. So we get completely different materials after a chemical change. We get a new substance. So anytime you talk about like reacting or making something new, that's going to be a chemical change. So burning, combusting, decomposing, rusting, those are all reactions, those are all chemical changes. So in this case, if we start with the same material, which is a compound made out of 2 elements, when it goes through a chemical change, we get something completely different because we've broken apart the particles that were attached or bonded together. Now they're separate, so that is representing a chemical change. We have new material at the end. We're going to focus a little bit on density, which is one of our physical properties. So density measures how compact the particles are in a certain amount of space. So if we look at these diagrams, and it's kind of increasing as we go across here, over on the left, it's representing particles where we have the least amount of them in the space. As we go across to the right, here we have a diagram where we have the most amount of particles in the same amount of space. So this is going to be a little bit rough when I go to draw this in, but as you go from left to right, we're going to be increasing the density. So you can just fill that in as best as you can. See how long this is taking. All right, so we're increasing density as we go across because we're increasing how compact the particles are in that amount of space. So a couple other things with density, and you've been seeing this in some of the activities in class, is when materials have different densities, that can affect which ones will sink or float in the same container. So an object or substance that has a higher density than the fluid in which it is put into will sink. So the greater the density, the lower it would go into if we had like a density column. An object or substance that has a lower density than the fluid in which it's put into will end up floating on it. So for example, water has a density of 1. If we put something that, liquid, another liquid or an object, and we find that it floats in water, we can make the assumption that it would have a density less than 1 because it's floating in water. If it sinks in water, then we would be able to say and make the assumption that that material has a density that's greater than 1 because it's sinking within water. It does not have to do with how heavy the material it is. When something sinks or floats, for us, we're really just focusing on their differences in density. So we do need to be able to complete some density calculations. You have this formula on the back of your Regents reference table. It gives you the formula, it tells you what everything is. So it's really a matter of identifying variables and rearranging them to solve for your missing one. So in this first one, we can identify from the reading that it has a volume of 45 centimeters cubed and a mass of 121.5 grams. So we would go ahead and fill in mass and volume into the formula. So you'd have this as your setup. You guys in Regions Chem don't have to show units, but it's helpful in figuring out what your final units would be. So we would just simply go ahead, divide the two numbers, and rounding off to the tenths place is what you normally do in Regions Chem. You get 2.7. So that would be your density of that metal based on its mass and volume. So this next one, we have a sample of gold, and we're given the volume, so we know how much space it takes up, which is 15 milliliters. And because we know it's gold, we know the density of it, which is 19.3 grams per milliliter. This one wants us to find mass. So here we're filling in density, volume, we're looking for M. You can use M instead of X here. I just find students are more comfortable solving for the missing variable when you have X. So we fill in our this should say 3 right here, and then our 15.0 milliliters. All you would simply do is just like when you're in Algebra 1, you're going to solve for X, you're just going to simply cross multiply these two. So think of 19.3 being over 1. When you cross multiply those, you'd be multiplying 19.3 and 15, you get 289.5. And then finally, here we're given density, and we're given mass, and we're looking for volume. This is usually the hardest one mathematically for students to find, just because we have an extra step in here compared to the one before. So we're going to go ahead and fill in density, and we fill in our mass based on our formula given to us, and I have X in place of volume. The first thing that most students do is they simply just cross multiply here. We think of 8 being over 1. So we end up here, 8 times X is equal to 24. Remember, whatever is next to X, that's what you're going to divide both sides by. So I go ahead and divide both sides by 8. So I would end up with 24 divided by 8, which would give me 3. So it's just a matter of paying attention to the formula, identifying variables, and then from there it's just using your math skills. Okay, that's it for this video. You are all set.